So for this first experiment, we are using exactly the same code as we used before the previous tutorial, but with some modifications. So in this first experiment, these are the parameters we are going to use. We're using a number of input channels equals 1, output channels 32, kernel size of 2048, and a stride of 512. So this is for the analysis part, and this is for the synthesis part of our autoencoder. Here we are going to use the introduction of the classic rock and roll song by AC/DC, Back in Black, and we are going to use one channel, the left or right channel, to train and the other channel to test, like we did in the previous example. We still use the same optimizer, the same loss function. We are using the mean squared error loss function. We are using the ADAM optimizer, and here is where things change. So here we are including this shift to the right, and is also called as round robin, and we are also introducing a different noise for every epoch. So when we train, have this loss going down. We train many epochs, and here we are going to plot the encoder and the decoder filter coefficients for the subband 0, and this is what we have here, the same as we did in our previous tutorial. Now we are going to test our model using the training set, and this is what we are doing here. We are making some predictions, and here is the target and the predicted signal, and we can also listen to it. So here is the input, the model, and it was trained. So it is the introduction of Back in Black by AC/DC with added noise, and it would sound like this. The target is exactly this same audio file, but without the noise. And the prediction, the output of our model, is given here. So observe that there is a bigger difference to the original signal, and the reconstructed version sounds very muffled. We can also test the model using a different file, so that file that was not used to train the model. So in this case is the other channel, so we use one channel to train, and we tested also our model with the training set, but now we are going to use a different, this is slightly different as it's the same song, but we are taking the other channel, and this is what we are doing here. Here is the original and the predicted signal, and we can also listen. So here is the input of the model. So we can hear that the noise is there. So this is we added this noise on purpose to train our model. And here is the output of the model, so the reconstructed. So this model never seen this file before. Of course, it's seen a very similar version of this file, which is the left channel or the right channel. But this is just for learning purposes. So you would use thousands of different audio files, play around with different hyperparameters and network architectures, but this is what we have for this tutorial. It's a starting point, and this is first experiment using a stride of 512. And we see that the noise is less present, but it also sounds very muffled. Here's the input with noise. So the denoise is more or less working, but the output is very muffled. So we also see that the shift sensitivity is not there anymore because of the way we trained. So here in the test version, so we're using the test for verification, and we are adding a shift of 100 samples. So this is what we're doing here, and we are also adding some noise here. So what we do is that we take, for training, we used one channel of a stereo audio file. So let's say we use the left channel. We added some noise and we trained our model, and we included this round robin. So we included this shift during epochs to try to minimize this shift and to have minimize the shift sensitivity. And it seems that we achieved this because when we are testing our model using a verification set, so it's a different audio file. So we trained with the left channel, now we're testing with the right channel, and we are adding here 100 sample shift, and we are also adding some noise.